type of requirement it applies to. You'll see how this works as it goes through the, if you go through the requirements catalog. And then it generates, the technique generates a set of tests. And this is the set of test IDs here. Here are the test cases themselves. And what I've also done in these set of tests that were generated, the 6 sets that were generated, I checked to see if this was something that would have been generated by the other techniques. So it wants us, the requirements catalog wants us to test -1, 0, and 1. And those are values that already would have been forced upon us by McCabe or generated by McCabe's technique. And then it wants us to test the maximum value that can occur, and that's or can be input. Excuse me. That's 2 billion and change on a 32-bit processor. And we would have tested that also with the statement branch condition loop kind of code flow coverage anyway. But there are some things that McCabe says that we should definitely do that we wouldn't necessarily have had to do. For example, he says that you should select a typical value, which I said 10 would be a typical value, so it produces this Fibonacci series that you see here. Typical value in the input range. And then also try a value where the input and is going to be different than the return. Notice that we return n unless the input is less than 1, in which case we always just, or excuse me, less than 0, in which case we always return -1 as a code saying that we got a invalid value. So it's saying you want to check that happens. You want to test that reassignment of the code. So it does tend to generate some tests that you wouldn't otherwise necessarily have looked at, and so thus it is an interesting technique and potentially useful. Okay, so that is sort of a roundup of the common techniques. Here, this slide shows a recap of the test design approach with Merrick's tool. You review the requirements, design, code, and structures, compare the elements of this checklist or catalog, and then you accumulate what Merrick referred to as clues, which were the test requirements to be run, and then you create tests that cover those. And one thing interesting that Merrick said was try to use as much variety in your input data as possible, because you might stumble across a bug that is hiding in there and not amenable to discovery. So that's another good insight from Merrick, that the other code coverage techniques say, well, it doesn't matter what input values you use as long as they force particular code flows or data flows, in the case of data flow coverage. Merrick said, no, it really does matter. You should try to have as much variety in your data as you possibly can. So we've looked at these different techniques, and we say, okay, well, the white box sounds like it could be useful, but how does this compare with other techniques that are out there? Well, basically, you've got static techniques like reviews and static analysis and so forth that involve testing without running, and those are going to identify bugs before, in some cases, before the bugs are built if you're doing a static review of a requirements or design specification. This is something that would typically involve, ideally, as many stakeholders as possible and happen during specification and development. And then there are a wide variety of tools available to do static analysis and support this. So it's a good idea to use static techniques, including code reviews, but also other things, prior to getting into coding. I mean, once you've created the code, then your opportunity to prevent bugs is gone. You're now going to have to just grind the bugs out. So as we've discussed, white box testing is testing how the system works, and the idea is to identify functions in the bugs or in the interfaces between or identify bugs in the functions, or the interfaces between functions. This is typically done by programmers as part of, say, a unit component or integration test, and there are also plenty of tools to support this, though, again, I'd be curious if any of you run across a data flow coverage tool. And then we have, of course, the black box tests, which would be, testing what the system does, looking for bugs in the results and the behavior of the system. And this is typically the domain of independent testers and often predominates at the higher levels of testing like integration, system, and acceptance. And as those of you who are testers know, there are plenty of tools to support this. Now, these techniques are complementary and can be can and should be used on every project, or just about every project, because they tend to find different kinds of bugs. They have different strengths. So by using a good mix of different techniques, you're going to tend to find a lot more bugs than if you just bang away with one set. Okay, so as I've said, measuring this stuff by hand, doing these code coverage and psychomatic complexity stuff, not something you're going to want to do for fun, but in some cases there are tools, but as I said, I'm interested in anybody's comments about data flow coverage tools, if anybody's seen one, or if anybody has seen a test catalog coverage tool. I'm not sure that would exist. Fortunately, I think Merrick's technique, like Whitaker's technique, is much more focused on leveraging the skills and experience of the tester. It's not as tedious. It's more of a kind of tips on how to explore the code from a white box perspective. Now, white box testing is good. White box testing is important. I would encourage you all to take it up if it's something that you can apply, or if you can't apply it yourself, to try to make sure that it is being applied by the programmers within the organizations that you're working with. But it's really important to not have a blind faith in white box testing. I think there is sometimes an overconfidence that, so if we test the units really well, then everything's going to be fine. And I think some of that is kind of embedded in some of the things that you hear people say about agile technologies or techniques these days. Oh well, we're going to thoroughly test the units during unit testing, and that reduces the need for subsequent system testing or acceptance testing, or at least it makes it a much lower effort. Now, that's sure it should be a lower effort, but I go back in this to Capers-Jones's studies, and he's come up with a figure from his studies across these thousands of organizations and projects that really unit testing is going to top out at about 50% of defect removal effectiveness. So in other words, you're only going to find and remove about half of the bugs. So what can't we find with unit testing? Why would it top out at 50%? Well, part of it is based on the fact that the developers are typically testing their own code, so there's an author bias issue in there. But there are other things that make white box testing not 100% effective against bugs. Of course, nothing is. One thing that you can't find with white box test, or what could be called bug